Welcome everybody. Now we are going to discuss 1-bit memory cell. So already we have seen difference between combinational circuit and sequential circuit. What is the difference? In case of combinational circuit, no memory element is required, and in case of sequential circuit, memory element is required. So now we are going to discuss the circuit that can act as 1-bit memory cell. So let's start. So see, this is circuit which can act as 1-bit memory cell. Means what? In this particular circuit, either you can store 1 or 0. You can store only 1-bit data, either 1 or 0. So in this circuit, you can see that there are two NAND gate N1 and NAND gate N2. So output of NAND gate N1 is suppose Q, and output of this second NAND gate is suppose Q prime. So here these two output, it is expected that these two output, they should be complement of each other. Means what? If Q is 1, then Q prime will be 0. If Q is 0, then Q prime will be 1. So this circuit can store 1-bit data. How it can store 1-bit data? That analysis we are going to see. So before discussing that analysis, let us see truth table of NAND gate. So this is truth table of NAND gate. So from this truth table, it is clear that if all inputs of NAND gate are 1 1, then output of NAND gate will be 0. Otherwise, output of NAND gate will be 1. Now, 1-bit memory cell is designed using two cross-coupled inverters, N1 and N2. Here, NAND gates are used as inverter. So please try to understand how we can implement 1-bit memory cell, how we can design 1-bit memory cell. So in order to design 1-bit memory cell, we will require two cross-coupled inverter. Okay, so you see in this diagram, you can see two inverter, one is N1 and second one is N2. So here you may say that these are not inverter, these are NAND gate. So already you are knowing that NAND gates act as a universal gate. Means by using NAND gate, it is possible to implement NOT gate, it is possible to implement AND gate, OR gate. Okay, so in order to perform NOT operation by using NAND gate, what you are supposed to do? You are supposed to connect both inputs of NAND gate together. So see here you can find only one input. Okay, means what? We have connected both inputs of NAND gate together. So that's why this particular NAND gate will act as a inverter. It will act as an inverter means here if I give 1, then output of this NAND gate will be 0. Here if I give input 0, then output of this NAND gate will be 1. Similarly for this NAND gate N2 also, it is also going to act as an inverter. Now these inverters are cross-coupled. So what is meant by cross-coupled inverter? So cross-coupled inverter means output of first inverter is given to input of second inverter, and output of second inverter is given as input to first inverter. Okay, so that's why these inverters are called as cross-coupled inverter. So very simple. In order to implement 1-bit memory cell, what we require? We will require two cross-coupled inverter. So how by using this two cross-coupled inverter we can implement 1-bit memory cell? So that again we are going to see. Okay. Before that, let's try to understand one more point. This particular circuit is known as bistable element. Why it is known as bistable element? As it contains only two state, that is logic 1 state, okay, which is also known as high state, and logic 0 state, which is known as low state. Okay, so see this output Q. Okay, this output Q will indicate state of this particular circuit. Output Q of this circuit will be either 0 or 1. So this Q cannot have any other value. Okay, so that's why this particular circuit is called as bistable. Okay, so this circuit is stable, will be stable either in state 0 or in state 1. Okay, it has only two states, so that's why it is called as bistable. Simple. Now let's try to perform analysis of this circuit. Now let's assume that this Q is 0. So Q is 0 means state of this particular circuit is 0, that is low state. Okay, already I told you that this Q represent state of this circuit. So this Q is given as input to N2, so input to N2 will be 0. Okay, N2 is acting as an inverter, so output of N2 will be 1. Okay, so this Q prime will be 1. Now this q prime is given as input to n1. So input to n1 will be 1. n1 is also acting as an inverter. So output of n1 will be 0. Okay. So we assume that q is 0, and after performing analysis of this circuit, again at the end we reach to 0. So this confirm our assumption. So now I can say that this particular circuit is stable. In which state? Low state. It is stable. So this state is not going to change. Please try to understand. In other words, I can say that in this circuit now 0 has been latched. Okay, 0 has been stored. It cannot be changed. This circuit now it is acting as a memory. Okay. Now consider another case. Now assume that q is 1. So if q is 1, then what will happen in this circuit? So here we have made this assumption that q is 1. So this q is 1, so that 1 will become input to n2. Output of n2 will be a 0. This 0 will become input to n1. Output of n1 will be 1. Okay. So again we started with this assumption, and after performing analysis at the end, again we reach to 1. So this confirm our assumption. Now I can say that this particular circuit is stable in high state. Now I can say that logic 1, bit 1 has been stored in this particular circuit. Okay. So in this way, this circuit can have either state 0 or 1. Okay. So that's why it is called as bistable element. Now let's make some conclusion about 1-bit memory cell. So the first conclusion is that output q and q prime are always complementary. Means what? If q is 0, then q prime must be 1. If q is 1, then q prime must be 0. Then this circuit has two stable state. Already we have seen that this circuit has two stable state. One is high state and second one is low state. So high state means this q will have value 1, and low state means this q will have value 0. Now if this circuit is in one state, then it continues to remain in this state. Okay. So in this circuit, if q is 1, then I can say that state of this circuit is 1. Okay. And this state will remain as it is. It is not going to change. Similarly, if it is in 0 state, then it continues to remain in this state only. So in other words, I can say that this particular circuit acts as 1-bit memory cell. Okay. So this particular circuit is going to act as 1-bit memory cell. So in this circuit, if I store 0, then that 0 will remain as it is. Later on, if I store suppose 1, then that 1 will remain as it is. It is not going to change. Okay, so that's why it is 1-bit memory cell. Now this circuit is also called as latch. Why it is called as latch? Because 1-bit data is getting latched, is getting stored in this circuit. So that's why it is also called as latch.